Okay, so the next part of precipitation is about hail. And just like all the previous presentations, you're going to answer the questions that are presented throughout this presentation in your notebook. First of all, what is hail? Here's a picture of hail. Hail is ice, but notice it's a little bit different than the types of ice or precipitation that we talked about previously. And remember, this is precipitation. That's a chunk of ice that fell from a cloud. So hail is a larger, jagged chunk of ice that falls specifically during a thunderstorm, and we'll get to that in a minute. Now, how is a hailstone different from sleet? Because they're both chunks of ice that fall from the sky. Well, first of all, notice the size difference. Hail is a much bigger. It's a large amount of raindrops that are frozen together, whereas sleet is a single frozen raindrop. And you can see the dime in both the pictures. This on the left, this is hail. This on the right, that is sleet. Another noticeable difference between sleet and hail is much more jagged. It is not uniform, whereas sleet is a nice, tiny little circle, very uniform, because it's one raindrop that froze. So how is a hailstone different than sleet? Well, a hailstone is much larger, which is only much larger than sleet, which is only a frozen raindrop, and hail is also irregular shape, where it's jagged because it's been tossed and turned inside of a thunderstorm. That's the significant differences between hail and sleet. Now, how is hail formed? This is a little bit more complex than some of our other forms of precipitation, which is what makes hail unique. So there's a short presentation here that you're going to sketch in your notebook as I go through it. So let's talk about hail forms, because it is a little bit different than all those other types of precipitation, and it only forms one way. The first thing we've got to have for hail formation is a rising cumulus cloud. I want to draw me a big thick cloud, but I'm going to have it be more vertical in nature. This is one of those rising cumulus cloud. More specifically, this is going to become a cumulonimbus cloud, one of those big, nasty storm clouds. This happens when the clouds suck in a lot of air, and we've got air just being pulled into this cloud. This is what we call an updraft. So the air is going up and it's taking the water up and it's making this cumulus cloud grow bigger and bigger and bigger. And now it starts to get to be kind of violent. This is what's called a cumulonimbus cloud. We've got to have a cumulonimbus cloud. We've got a big, thick, nasty thunderstorm type of cloud. Well, here's what happens. We have a piece of water up there that is frozen chunk of water, and it gets too heavy and it starts to fall down. That's water falling from a cloud, and we know that that happens from clouds. Now, at a certain point, remember, at a certain point, my frozen precipitation, my frozen piece of ice, which is how all precipitation starts, is going to get low enough that it's going to melt. At some point, you've got a freezing / melting point. For argument's sake, let's say this is my 32-degree line, because we know that's where water freezes and or melts. So here's what happens. First step, the water falls from a cloud and then melts at a certain point. Water falls from my cumulonimbus cloud and it melts into liquid at some point. And that's the imaginary. That line could be down here, it could be up here, but at some point this water melts and now down here it is a liquid. But because of the nature of this cloud, it's a cumulonimbus cloud, it's still sucking in air. And the air is pushing up, so my little piece of water that has fallen now gets pushed back up. It gets pushed back up to there. So the second thing that's got to happen is that my updraft pushes my water, think of it as my raindrop, back up. Now here's the thing. As this guy has dropped, and now he's being pushed back up, he's running into other pieces of water that are on their way down. So the water starts to stick together and form a bigger clump. So as my water gets pushed back up, it collides with other water in the air, and they stick together, make now a bigger clump of water. Now look where my water winds up. It winds up back above the freezing point. So it's pushed above the freezing line. So now it's back to being ice, but it's a bigger chunk of ice because it's not just one raindrop now. It's a bunch of raindrops that have been squished together that now all froze together up here. What happens is this over and over. So this chunk of water falls down, melts a little bit, gets pushed back up, picks up some more water, falls back down, and this it's melting and freezing and picking up more water over and over again to where now you have a bigger chunk of ice. And the ice isn't a nice, smooth, single, pretty raindrop anymore either. It's a big, clumpy, kind of jagged piece of ice because water was stuck at it from all different sides. It melted on different sides. It's a very irregular pattern because this is not a neat, pretty line. It's going up and down and sideways and constantly changing. Now, at some point, the ice gets too big, or the updrafts start to die down. And that's what happens here. Kind of the last step of my hail formation. The ice is so large that it falls to the ground. So if you're standing right here, what you see falling down is not a raindrop. It's not a single frozen raindrop like sleet. It's a big chunk of ice. Generally looks kind of jagged, looks uneven, and can be quite large. This is what we call hail, and this is the only way in which hail forms. So what weather event will produce hail? Hail only comes out of thunderstorms because that's when you get the cumulonimbus clouds that have those strong updrafts that can make that process happen. So hail is only produced out of thunderstorms. Now, when is hail most likely to form? Hail is not a winter event because you need the hot and the cold, and you need those big thunderstorms, and that's usually spring or summer because that's when thunderstorms are most common. Now, hailstones are described by their size, and they're usually related to very common objects like coins or balls. So you can see some of the examples here. There's pea-size hail, penny, quarter, ping pong, golf ball, tennis ball, baseball, softball size. List some of these items so that you can have an idea of, well, how do we describe how big they are? Because nobody measures them with a tape measure. They say, oh, it's baseball size hail, or it's penny sized hail. Here's an example of hail that would be a little bit bigger than baseball. We'd probably call this softball size hail. And yes, hail can get that big in a very powerful thunderstorm. Imagine if that thing came down on top of your head. The world record was in July 23rd, 2010. It was 8 inches across, was almost 2 pounds in weight. And this is very deceptive because it might have lost as much as about 40% of its mass before it was found. Plus, it hit a house. So certainly some of it broke off before somebody went outside and picked it up and put it in the freezer. Now, hail causes a lot of damage, a lot more so than other precipitation because it's big, huge chunks of ice coming out of the sky. It's especially bad for cars because your cars are outside, they're made of metal, and if you throw little pieces of ice at your car, especially when it falls from 30,000 feet, it gets going pretty fast, it can ding your car. It can break your car windshield. It can put all kinds of crazy dents into a car. Car dealerships hate hailstorms because all their cars are sitting outside and there's nothing they can do to protect their cars from getting dinged up like this. You can do some things to protect your cars if they are outside. I've actually seen one of these out in Mississippi one time. It's a hail protector for a car. Basically, you inflate it when you think there's going to be a really bad thunderstorm, and that way hail just hits this and bounces off. Hail is another reason why airplanes do not fly through thunderstorms. Remember, we talked about this before with downburst and microburst, but planes stay away from hailstorms or thunderstorms because of hail. Planes flying at 300, 400, 500 miles an hour or whatever, and they're going through a bunch of golf ball sized pieces of ice. Well, you can see what it can do to an airplane. You can see what it does to landscaping. A golf course, it tears up the ground. Your house is sitting outside, and houses suffer damage from hail every year. You can see the siding on this house has been dinged up. We can see we got a broken window up here. The storm must have been blowing the hail this direction. Most of the time, the hail is going to hit the top of the house. So the roofs of houses are especially prone to be damaged by hailstorms. Well, when your shingles get torn up like this, they don't work very well to repel water off the roof anymore. And you basically have to have your roof rebuilt, which could be $20,000, $30,000, $40,000. So hailstorms are very expensive for homeowners. Hail causes about $1 billion, that's B with a billion, not million, in damage to property and crops. Because remember, if a hailstorm hits a cornfield, it might tear up all of the corn plants, and that's a loss. That's money the farmer can't get back. This is a lot more than tornadoes. We associate tornadoes with being very destructive, but actually it's hailstorms that cost a lot more money to people. There was one that hit in St. Louis that was $2 billion in damage from everybody's damaged roof, damaged cars, so forth and so on. It was one of the most expensive weather disasters in history. Here's somebody who got caught out in a hailstorm. This was a guy who was a farmer, and he was out way away from any shelter, and you see he got beat up pretty good by the falling hailstones. There are 2 instances where people were actually killed by hail. In 1979, there was an infant. Lady was outside, was running for cover, and a golf ball-sized piece of hail hit an infant and killed the baby. And in 1939, there was a farmer who died of his injuries. He was outside, open field, got caught during a severe hailstorm. And same thing with another boy in 1928 in Texas, got caught out in the open. This is why farmers tended to be very in tune to the weather, because they had to be aware of such things. So question number 7 lists some of the examples of the type of damage that can be caused by hail. Dents on cars, breaking windows either on your house or on a car, destroying landscaping or your lawn, and first and foremost is damaging the roofs. That's how it's going to impact you more personally necessarily than the others. Now, do we get hail in Georgia? The answer is yes. The picture in the upper right, that's my back deck on a spring afternoon, spring evening. The picture in the lower left, that's the Centennial Centennial Stadium field. This was a really bad hailstorm we had, and this was actually during the school day. April 20th, 2015. The whole field got covered with hailstones, and you can see the size of them on the right. They were about quarter size hail, so enough to do damage to your cars. So that's the end of the presentation. This time you're going to bring me your notes. You're going to get a done stamp for completing the notes, and you'll take the notes check that covers precipitation types, including hail.